Chapter 11, Example 1. Damage stability calculation, added weight method. The added weight method is based on the assumption that the flooded compartment was intentionally flooded with seawater and the added weight is considered as an additional load. So the first thing we need to do is to calculate the volume and the mass for the barge before it was flooded. So your volume is your length times your breadth times your depth. So it's 32 meters times 8 meters times 2 meters. So your volume is 512 cubic meters. And this is before flooding. Now the mass is your density times the volume. And we're in salt water. So your density is 1.025 times the volume of 512. So the displacement of the barge before flooding was 524.8 tons. So now we need to calculate the volume and the mass of the barge after flooding. So the volume again is your length times your breadth times your depth. Now they indicated that the draft increased by an additional 2 meters, so it's 32 times 8 times 4. So your volume is 1,024 cubic meters. And this is the volume after flooding. So to calculate your mass, again, it's your density times the volume. And we're in salt water, so the density is 1.025 times the volume of 1,024. So we get a displacement of the barge after flooding of 1,049.6 tons. So now we need to calculate our shift of G. And this is our G to G1 equals the weight times the distance, and that's the distance from the original kg to the kg of the added weight, divided by your original weight plus the weight that was added. So it's 524.8 times the original kg was 2.9 meters. And the kg of the added weight is 2 meters, so 2.9 minus 2, divided by the original weight, 524.8 tons, plus the added weight, 524.8 tons. So we end up with 472.32 ton meters divided by 1,049.6 tons. So our shift of G to G1 is 0.45 meters. So now we can calculate our new kg. And our new kg will be the original kg minus G to G1. The original kg was 2.9 meters. We calculated G to G1 to be 0.45, so we subtract that from the original kg. And our new kg is 2.45 meters. So next we calculate our free surface effect. And for our free surface effect, That's going to be our inertia divided by our volume, which is our length times our breadth cubed, divided by 12 times the volume. So that's 16 meters times 8 cubed, divided by 12 times 1,024 cubic meters. So we end up with a free surface effect of 0.66 meters. Now our KB, this is a box-shaped vessel, so our KB is going to be half of our draft. So therefore our KB is going to be 2 meters. Now we can calculate our BM. And our BM is our length times our breadth cubed, divided by 12 times the volume. So that's going to be 32 times 8 cubed, divided by 12 times 1,024. So our BM is 1.33 meters. So now that we can calculate our Km, and our Km is equal to our Kb plus our BM. Your Kb is 2, the BM is 1.33. So your Km is 3.33 meters. Now we're able to calculate our dry GM and our wet GM. So the formula for our dry GM is our Km minus our Kg. We calculated the Km to be 3.33 meters. Minus the Kg of 2.45 meters. So we get a dry GM of 0.883 meters. Now that we've calculated the dry GM, we can calculate our wet GM by applying our free surface effect. So for the wet GM, it's our dry GM minus the free surface effect. So our dry GM was 0.883 meters. We're going to subtract the free surface effect, which was 0.66 meters. So our wet GM will be 0.217 meters.